Hello everyone, welcome back. This is Engineer Wasabi, and in this video we'll be looking at a quick question that was presented in chemistry. So basically we have the question as it is. So before we begin, do not forget to like and subscribe to the channel. Alright, so the question reads, choose the letter that best describes each of the following descriptions of gas laws. Each answer may be used more than once. Okay. Okay, let's get to it. So let's start with the first one. The volume is directly proportional to the moles at constant pressure and temperature. This one is basically Charles' law. Charles. Okay. Now my Charles is not Charlesing. Charles' law. Okay, so we both know that Charles' law states that the volume of a gas is directly proportional to its absolute temperature at constant pressure and moles of gas. So basically, Charles' law best describes 1. 2 says the kinetic energy is equivalent to half mv squared. So anything relating to kinetic energy is the kinetic molecular theory. So for this one, that's saying choose the letter. So basically this for 1 is H. So for 2, we're looking at the kinetic molecular theory. Kinetic molecular theory, which is, sorry, Charles' law is not H. Sorry about that. Charles' law is on C. C for Charles' law. So H is the one that represents the kinetic molecular theory. The kinetic molecular theory explains the behavior of gases in terms of the motion of their particles. The kinetic energy of a gas is always proportional to the temperature of a gas. Then looking at 3, which says temperature is directly proportional to the pressure at constant volume and moles. So for 3, the one that represents temperature being directly proportional to the pressure at constant volume and moles is the GUY-LUSSAC'S law. The GUY-LUSSAC'S law. GUY-LUSSAC'S law, and basically in our case that's B. So GUY-LUSSAC'S law states that the pressure of a gas is directly proportional to its absolute temperature at constant volume and moles of gas. Then if we look at 4 says equal volumes of different gases at the same temperature and pressure contains the same number of molecules or moles. So basically, if you just clearly try to understand this, it will take you back to grade 12. Equal volumes of different gases at the same temperature and pressure contains the same number of molecules or more. So this is called the Avogadro's law. So we're having the Avogadro's law. And basically, this letter that represents this is E. So the Avogadro's law states that the equal volumes of gases at the same temperature and pressure contains the same number of molecules, which are sometimes, in this case, we can say the moles rather. Then 5 says that N is equivalent to PV over RT. So this equation here on 5 represents the ideal gas law. The ideal gas law. And the ideal gas law in this case is G. So the ideal gas law is a combination of Boyle's law, Charles' law, and the Avogadro's law. It relates the pressure, volume, temperature, and the number of moles of a gas. 6 says pressure and moles are held constant. Pressure and moles are held constant. So when the pressure and moles are held constant, the law that we look at is known as the Boyle's law. And Boyle's law is on D. On 7, pressure is inversely proportional to volume at constant moles and temperature. So when the pressure is inversely proportional to volume at constant moles and temperature, we're looking at the Boyle's law again. because Boyle's law is the one that states that the volume of a gas will be inversely proportional to the pressure at constant temperature and moles of the gas. Be mindful that there is that terminology of me saying constant in my explanation. The temperature and the pressure is constant, but again, I'm also saying that the volume of the gas is inversely proportional to the constant values, which is the pressure and the temperature of those particular moles. So we also have Boyle's law, which is D again. So 8 says T1 is equal to PV of 1 over PV of 2. So 8 represents what is known as the combined gas law. So the combined gas law, let me just explain a bit about the combined gas law, which is F in this case. So the combined gas law is a combination of Boyle's law, Charles' law, and GUY-LUSSAC'S law. It relates the pressure, volume, temperature, and the number of moles of the gas when all other variables are changing. Be mindful about that. Then basically, if we move on to the other aspect, which we have as 9 in this case, which states that gas particles themselves have zero volume. Gas particles themselves have zero volume. All right, so gas particles themselves having zero volume looks at what is known as the kinetic molecular theory. Kinetic molecular theory. Which is basically H. So the kinetic molecular theory explains that gas particles themselves have zero volume. 10 says that we're looking at a law or theory rather that shows the ratio of gas A's speed to gas B's speed. So that law is called the Graham's law. In most cases, there are questions that will arise when they'll ask you to derive this particular law. And basically, I expect everybody to at least have an idea of these laws, like even how to derive some of them. You should know that. So the Graham's law shows the ratio of the speed of gas A to the speed of another gas B. And its all theory is based on the kinetic theory of gases. Then let's look at the last one, which is basically 11, which says the total pressure of a mixture of gases equals the sum of the partial pressures of the individual gases. Now, this is basically known as the Dalton's law of partial pressure. So we're having Dalton's law of partial pressure. All right, so Dalton's law of partial pressures states that the total pressure of a mixture of gases is equal to the sum of the partial pressures of the individual gases. I hope that's clear. So this is basically how you go about solving this question. If you have queries, you can always reach out to me on WhatsApp on the line 077 149 5252. Remember, slow progress is better than no progress, and let us strategize before becoming a statistic, and let's try and push for that A+.